All right, talk to me about number 1. What letter did you find first? Y. Okay, how much is Y? How'd you get that? Perfect. So line has to equal 180. Two angles creating a straight angle. So those two have to add up to 180. 180 minus 110 gives you 70. Okay? Somebody else talk to me. What's the next step? Doesn't matter which letter you find. Yeah. How'd you get 30? Yep. So adding the 110 and the 40 together and subtracting from 180. Do we need to show that work? No. You can just do the subtraction. Last but not least, find me Z. Somebody new. Come on, everybody had this one done. Yeah. Okay. There we go. So you did the whole big triangle and did 180 minus what? Because you use the 90 and the 40 together. Okay, and then your step after that, because that's 180 minus 130, you said that gave you, so it's 50 for the whole big angle, but you knew this one was 30, so you're telling me how much is left? 20. Absolutely. So she went big triangle, took out the two angles of the big triangle we know, figured out what the whole big triangle's angle would be on that peak, and then already knew that x, or I'm sorry, yeah, x is 30, subtracted the two of them. Did somebody do it a different way? Yeah. There we go. There's the other little triangle that you could look at, and you've got a 90 up there on top, so the other two have to add up to 90. One of them's already 70. You can do the little triangle too. It doesn't matter which way you do it, big triangle or little triangle. It's why on that quiz I didn't make you write down reasons. I just had you write down the numbers. Good? All right, then in number 2, you need to tell me what F and what G are. What's F? How'd you get 132? Okay, so if you find G first, what do you do to get G? And then to get F? Okay. Did anybody do it a different way? What do you know about those two remote interior angles compared to this exterior angle? They'll add up to x. So you could have just done 61 plus 71 right away to get that 132, and then did 180 minus 132 to get 48. So either direction works. Either you find the one in the triangle and subtract from 180 to get the one out, or you figure out what the outside one is because you know two of the inside, the remote ones, and then subtract from 180 to get the one that's inside. What kind of triangle is that then? If I have that this is 48. Acute and scalene. Good. Sides. Go ahead. No marks showing me the sides are equal. And the angles aren't equal, right? So scalene is no congruent sides. And since there's no marks on the picture, we know there's no congruent sides. If the angles inside had all been 60, what kind of triangle would it have been? Equiangular. Somebody else give me another name. Equilateral. Give me another name. Isosceles. One more. Acute. There it is. So in that case, if you know the 360s, You can go to the side lengths being equal. But because these are all different angles, we don't know the side lengths are equal. In fact, we know they have to be different because all the angle sides are different.
What if two of those angles were the same? What kind of triangle would that be?
Two angles congruent. Isosceles, very nice. Two angles congruent means two sides congruent. Good? All right, so then we got number 4. We have to draw an isosceles right triangle. What markings do I have on it to make it isosceles? Okay, somebody else tell me what the square in the bottom left corner gives me. The right angle. Okay, now we need, how are we going to get isosceles? Any two sides for those two tick marks? Yeah. Technically, yes. If you drew me an isosceles triangle and just marked the two base angles congruent, yes, that would be isosceles. Why does it have to be the two that make the 90-degree angle? What do we know about that other side? Hypotenuse, and it's longer than the other two. So the two congruent ones have to be on the sides making the right angle. Again, practice problems here. If you have anything wrong, you should be paying close attention right now and fixing it. I want to give you points. I don't want to take this point away from you. That's why we go through the answers. Okay, so fix it if it's wrong. All right, number 5. What kind of triangle is it from what we just talked about? It is acute. What else is it? It's isosceles. How do we know it's isosceles? Perfect. We've got those congruent angle marks showing me the base angles are congruent. All right, talk me through it. What do we got to do? Okay, stop right there. Pick up where she left off. Somebody else? 2. What do I get? 77. Very nice. So we took out what we'd used up, the 26, out of our 180, and then we divided by 2 because we have 2 equal angles, so we got to split what's left into 2 equal parts. Sounds remarkably like the ACT problem. Oddly enough, just a different shape. All right, the ratio of the acute angles in a right triangle is 1 to 8. Find the angles. What do we got to do? I can draw a picture. Absolutely. We have a right triangle, so I know there's a right angle in it. What else do I know? Yeah. The other two angles have a ratio of 1 to 8. So if I put a 1 and an 8 there, that doesn't add up, right? Perfect. We got to put an X next to it because that ratio got reduced from 2 other numbers. How did it get reduced? We divided them by the same thing. We did this in class. We did it as my ratio is 1 to 8. And then we went down to the angle and said, I'm sorry, we started at the angle. My bad. We had our 2 angles. We divided by the same thing to get to the ratio of 1 to 8. Now we want to go back up. How do you undo division? Multiplication. So we get the 1x and the 8x. Do I care which way you visually figure out where the 1x and the 8x are? No. Do I even care if you write the 1x and the 8x? No. What I care about is whether or not you can figure out what the angles are and that you show me some kind of thought process with it. So pick a way, whichever way you want. Tell me, how do I get what these angles are? Somebody new, talk to me. Okay, somebody else tell me, why is she saying 9x equals 90? I don't get it. I don't have enough stuff. Okay, somebody else tell me why it equals 90. Where'd the 90 come from? Go. All right, so we got rid of that right angle to get 90. That's left for the other two. Am I writing way more work than you would have? Absolutely. I want to make sure we're talking through the process. Okay, since 9x equals 90, what's x? So then what are my angles? How'd you get 10 and 80? Perfect. So you got that the multiplier was 10. We take 1 times 10 and 8 times 10. Questions? Okay, now as I walked around, some people actually just wrote down 90 divided by 9 and then gave me my two angles. 100% fine. You're showing me your thought process. Okay, some of you might need more of the algebra. Some people, when I walked them through, did 1x plus 8x equals 180, and then I asked a question. What question do you think I asked? Where's the other angle? Because that's only 2 out of my 3 angles, and we said equal to 180. So what would have had to be here for this equation? And some people solved that equation. I don't care which one you did or which way you did it. Whether you're showing me the arithmetic involved or if you're showing me the algebra, it doesn't matter. It's your call. Whatever makes the most sense to you. All right, last but not least, perimeter of a parallelogram 76 and one side measures 14 can be determined what the lengths in inches of the other 3 sides are. And I saw a lot of people circling E right away. But then I suggested drawing yourself a picture. What do you know a parallelogram looks like? How many sides? And what do we know about each pair of sides? They're parallel. So could I draw a rectangle? 4-sided, both pairs of opposite sides are parallel. Could I have drawn it like this? Absolutely. What do you know about opposite sides in that parallelogram? They're parallel. What else do we know about them? They're congruent. So no matter which way you did it, yes, we know they're parallel, but we also know if that's 14, that one's 14. Okay, I'm just going to draw this on one of them rather than have both. What do I do now? Okay, somebody else tell me why she's adding them up and subtracting from 76. Why is it 48? What does that do for me? Okay, so 48. Perfect. Somebody else tell me why he wants to divide it by 2? So no matter what, like if I had a shape like this, we are finding perimeter, but I could tell you that this is 14 and this is 14. Would I then divide what's left by 2? The 2 sides are equal. We know opposite sides are congruent. So 48 divided by 2 gives us 24. So then I look down my list, and there's a 14 in all of them. But what's the only one that has the 24? So I think what stops people from doing this is they read the words and they're like, I don't know what the other 3 sides are, and kept moving. Draw yourself a picture. Because once you see the picture of a parallelogram, you're like, oh yeah, the other side's 14. So I do know at least one other side. So I have some information, which means I can find the other 2 sides beyond the one that we just found. All right, there does need to be some work on the ACT review. Showing me that you're subtracting 28 from 76 and getting 48. I'm good with that being the only math because most of you can divide 48 by 2 in your head. But you got to show me something, a picture, the subtraction, something to show me you thought through this process. Okay? The only problems that do not need work. 1, 2, 3 is just words. 4. So 5, 6, and the ACT 7. 5, 6, and 7 all need some kind of work shown. Once you've made sure that there is work shown, make sure your name is on it and pass it up. All right, on the top of those notes, I have two sets of pictures. One is labeled polygons, the other one is not polygons. So I want to come up with what a definition of a polygon is. Take a look at those, talk to the person next to you, and see if you can come up with 3 different things that makes the polygons polygons that the not polygons don't have. That would be turn and talk right now. Ready, set, go. Something that is true of the polygons that's not true of the not polygons. All what? All the lines touch. I'm going to kind of tighten that up and just say it's closed. All the lines touch. They all close up that shape. So if it's closed, how many sides does it have to be closed? 3 or more. Some of these all have 4, but as long as you have 3 or more, you know it's going to be closed. Okay, give me another thing that those polygons had. Somebody knew. Somebody back there said something. Straight sides. Meaning that there are no what? There's no curves. All right, so we've got straight. No curves. One more rule out there, one more thing that you can see. What do you mean overlap? I think you have it, I just don't. So they potentially, you could cut it pieces. The lines are overlapping. Okay, so how can we say that? Because the lines overlapping is bad. There does not have to be one side parallel because is a triangle a polygon? Yeah. So we don't have to have a parallel. Sometimes we do have parallel sides in there, but we don't have to. Let's go back to that line overlapping or crossing each other in the not polygons. How could we write that as something a polygon does have now that we acknowledged what the thing it can't have is? Well, they all intersect though. Don't these two intersect right here? We gotta make it better. Because intersect just means hit each other, right? So these hit each other. They're making a shape. Agreed. Keep going. Think about where they hit each other. They hit each other in the middle on the not a polygon. Where do they hit each other on the polygon? They form a point where? At a vertex. Where's that vertex located on the polygon? At the top, at the corner, right? So they are only intersecting at the vertices. So we can't have them hitting in the middle of the shape. They can only intersect at the corners or the vertices of the shape. Is that good? Okay, so that's our definition of a polygon. We know they have to be closed. So it's got to be 3 or more sides. They've got to be straight sides, no curves, and they can only intersect at the corners. Once we have that, we have ways of naming it. Naming is different than classifying. If we are naming it, we're giving this particular polygon's values or names for how we can identify I'm talking about this one and not some other one. Okay? So when we name, we start at any vertex and we list the in order, clockwise or counterclockwise. This is what I talked about back in chapter 1 when I said when we were naming the planes that I would always go around clockwise or counterclockwise. So when we got to chapter 3, it wouldn't screw you up. So pick me a letter to start with. I heard D first. You could have started at H. Go either clockwise or counterclockwise around the shape. Okay? Absolutely. 6 corners, 6 letters. Your name is just the 6 letters in order, either clockwise or counterclockwise. Somebody said H, I could have started at H. I could have done H, D, B, G, M, K. Doesn't matter which way you go. When I give it to you on a quiz, I will tell you which letter to start with, but I won't tell you which way to go. So you can go either way. Good? All right, what are the sides of a polygon? What object? What is this in geometry? A segment. So what are we going to write when we write segments? 2 letters and a segment bar. Perfect. Give me a side of this shape. When I do this, just to keep myself organized so I don't lose track of what sides I've listed, I now go around clockwise or counterclockwise from DH. So if I go DH, then my next one to the right would be? Okay, segment bar over the top. Then what? Okay, M, another one after that. Somebody new. Perfect. MG, then the next one is GB. Somebody give me another one. BD. And the moment that I got back to my first letter, I know I'm done. I have 6 sides, I have 6 segments. Does that mean you have to list them in order? No. You can list them whatever order you want to list them in. That's my way of organizing me to make sure I don't miss a side. I started a letter and then I go around clockwise or counterclockwise, taking 2 letters at a time with the segment bar. All right, how many vertices are there? 6, because there's 6 corners, right? Vertices are just a vertex. Multiple vertex makes vertices. What are the letters that are on those vertices? All 6 of the letters, right? The only difference between naming it and naming the vertices is putting a comma there. So my vertices are D, comma, H, K, M, G, and B. So literally, if you can name it, you can do the vertices because all you got to do is put a comma in between each of them, where in the name I didn't put a comma. How many angles are at each vertice, or at each vertex? 1. So can I name it with 1 letter? So what's the only difference when I have to write the angles? Put the angle symbol. So we've got angle D, angle H, angle K, angle M, angle G, angle B. You can see off to the left there, this is a test question. If I give you a 6-sided shape for a test question, I'm going to show you what the points would come out as. You get 1 point for naming it correctly. You get 6 points for each of the, 1 for each of the sides, plus 1 for the segment bar. That's 7 points. You get 1 point for each of the vertices. That's 6. You get 1 point for each of the angles, plus a point for the angle sign. How many point question is this? 21 points. Just for being able to name it correctly if I give you a hexagon. Obviously, I give you a 4-sided or a 5-sided or a 3-sided, those numbers go down, right? But just think about the effect that a problem like this could have on a quiz grade. It's pretty big, yes? You've got to know. Naming is just going around the shape, all the letters in order. What are the sides? What are the vertices? What are the angles? Does that make sense? Again, naming them, we name them or we classify them, excuse me, by the number of sides. So naming it is go around the shape, give me the vertice names. Classifying is what shape actually are they. So a 3-sided shape, you know this is 4-sided. Say again. Square is one of them. Rectangle is one of them. Parallelogram is another one. Trapezoid is another one. Give me broad category. Because you just gave me 5 different ones, so I can't name a 4-sided object by one of those because there's 5 different ones. Say again? Parallelogram's another one. You got to go broader. Think of the number of sides it has. Quadrilateral, very nice. Quad for 4. Tri for 3. 5. Sometimes it's shaped like a house. Pentagon, very nice. There's a big old house out in Washington, D.C. that holds our military people. It's called the Pentagon. You know what it's shaped like? A pentagon. It's amazing. The architects back in the day, I tell you. All right, 6. Say again. Hexagon, very nice. It's that Halloween time of the year. Witches put hexes on you. Think of the bad number that you associate with evilness. It's got a 6 in it, right? It's actually got 3 6s. Bad idea to say it out loud, though. So we got a hexagon. This one I'm not sure you learned. 7. Ideas? It is similar to hexagon. Octagon is 8. Agreed. Octo for 8, like octopus. Does anybody know that prefix or whatever the front end of the word is for 7? Heptagon. H-E-P-T. Octagon. Typically speaking, that one's new for most people. 9 is also usually new. Ideas? Yeah, this is a new one. Non-agon. What about 10? 10 years. Decagon, there it is. 10 years is a decade. 10-sided polygon is a decagon. Do you know 12? Do. Decagon. Decagon for the 10, do for 2. So 2 more than the 10, dodecagon. So of those that I just listed, more than likely you may have to do some memorizing of 7, 9, and 12, where those were the kind of the new terms. The other terms you've worked with throughout the years. And we're talking from about, I want to say kindergarten on, you've had some of these. Just depends on whether they gave it the formal name or not, right? But we've been going through my kids' elementary school with them. We've been doing shapes like this forever, from the start. So now you got to have those names. When we put this on a quiz, I will give you the list of names. I will not put them in order. So it won't be triangle, quadrilateral, pentagon, hexagon, so you can figure out, oh, it's 3, 4, 5, 6. This is which each one is. They're going to be mixed up, but the names will be there. You will need to be able to, if I give you a number of sides, tell me the name. If I give you the name, tell me the number of sides. But you will have a word bank that has the list of the names. You just got to be able to pick out which goes with which. Now, those are the ones that have special names. Everything else, we just put the word gone at the end. So 11 is an 11 gone. 13 is a 13 gone. A 14 gone. A 200 gone. We just like that word gone. It's kind of fun to say. Because they're all polygons. Polygon ends with gone. So poly is for many, right? So we're just telling how many gone we have. So we put the number in for poly and we leave the word gone. Good? All right. Then we need to also talk about the type of polygon based on concave or convex. If you look at those concave and those convex, tell me the difference. Concave versus convex. Yeah. Perfect. Concave goes in, convex goes out. So when I say goes in, I usually say caves in to help me remember the word. Because it's concave, it caves in. And then, for lack of another word, goes out or bubbles out, like however you want to think about that. The technical reason that it's concave versus convex, and do I expect you 100% to be able to repeat this to me? No, but I want you to understand why. Is that a diagonal can be drawn outside the shape. How do I create a diagonal? What do I have to connect to make a diagonal? To what? Two vertices. Perfect. So if I look at this concave one, I can take this vertex to this vertex, and I can draw the diagonal outside. But if I try that on the convex, no matter which two I decide to connect, no matter what, all my diagonals are inside. Even if it was a triangle, if I connect vertex to vertex, am I outside the triangle? No, I'm just forming the triangle, right? So all of my diagonals are either inside or making the shape for convex, excuse me. Concave, I could do at least one outside. So it caves in. There's an ability to connect outside the shape. What you will always assume is convex, unless it tells you differently. Why? Because when there's convex, we can come up with some rules that help us find values inside of it. When it's concave, those rules no longer apply because it caved in. So things are adding differently than they did before. Okay? All right. We good? How many degrees in a triangle? All right. I want you to take this four-sided object, which is called a quadrilateral. Very nice. I want you to create triangles only by making a diagonal, and your diagonals cannot overlap or intersect each other. How many triangles can you put in there without letting your diagonals hit each other? Without them being able to hit each other. Diagonal has to go what to what? Vertex to vertex. So can I hit like the bottom of the middle? No, because that's not a vertex. Connect vertex to vertex without your diagonals hitting each other. How many triangles did you just make? Two. Tell me where you drew. Did anybody draw it the other way? Agreed. No matter what, it's the same. I'm going to try and draw that a little bit better for you. Still only two triangles, yes? Okay. So the interior angles are inside this object, right? If I add up this angle, this angle, this angle in that right triangle, or the triangle on the right, and these three angles, will I get all of the angles in the quadrilateral? Will it add up to everything that was there to start? Yeah? Because that part plus that part is this whole angle. This part and this part are this whole angle. So how many degrees are there in my quadrilateral? 360, how'd you get that? Beautiful. Do the same thing for the 5 and the 6. Put in your triangles. Remember, your diagonals cannot hit each other, and you must connect vertex to vertex. Corner to corner, put the triangles in. Connecting vertex to vertex in the pentagon and in the hexagon, you can do it a bunch of different ways, so don't feel like you're not doing it right. Once you have it, write down how many triangles you have, and then figure out how many degrees are in each shape. All right, tell me where to draw on this pentagon. This one? Okay. Like that. Okay, what else? From here up. Center over. Did everybody draw that in? Like that? No. How many triangles did you get if you didn't draw it this way? 3. Does it matter where you draw your diagonals, but will you still get 3? Okay, so we've got 3 triangles times 180. How many degrees? Okay, somebody new, tell me how you drew in the hexagon. Go. So straight down. Perfect. Left to right or right to left? Like that. Okay. Did everybody do it that way? Even if you didn't draw it this way, how many triangles did you get? Times 180. Okay. I don't want to have to draw the triangles. Because if I see a 100-sided object, I do not want to have to figure out where to draw my triangles in. Can you come up with a pattern that takes you from the number of sides to the sum? Turn and talk to somebody near you. See if you can come up with a rule that will get us from number of sides to the angle sum. Super fast, and I actually think I heard people talk to me. Subtracting by 2. Number of sides subtracting by 2. So if I go here and I subtract 2, that gives me my triangles. Here I subtract 2, I get to my triangles. There I subtract by 2, I get to my triangles. So I can take my number of sides minus 2 to get my number of triangles. Then what do I have to do to get the total sum? Times 180. Perfect. So number of sides minus 2 equals 180. And I'm just going to draw an arrow here and say n is number of sides, just in case you didn't understand that part of the formula. Which means you should be able to find the 15 gone below, because what do? 15 subtract 2 and then times 180. Perfect. Do those 4 at the bottom. Give me the angle, total interior angle sum of those 4 different polygons. Turn and check with the people around you, see if they got the same numbers. When you do this on a quiz or a test for me, I do expect to see the numbers that you're typing into your calculator. For some of you, that may be the number after you already subtracted 2. For some of you, it'll be the formula. Don't care. Talk to me. What do you got for that 15 gun? 2000 what? I'm sorry. Pat? Okay. What about the 20 gun? This is why I had to confirm my numbers on the first one because I remember those ones just flipped numbers. Are we okay on those two values? Okay, what about decagon? 1440 is what I heard. And how many sides in a dodecagon? Which gives me questions on that. Okay, again, on a quiz or a test, either showing me the formula like I just wrote it out, or some people just write 13 times 180. That's fine too, because I can see you subtracted your 2 to get to your number of triangles. Good? All right, flip to the next side. The sum of the angles is 720. How would we work backwards to get the number of sides? Think about your formula. Perfect. Because the very last thing we did was multiply 180 to work backwards, we divide. What do we get then? I heard 4 and I heard 6. What is 720 divided by 180? 4. How did somebody get 6? Why do I have to add 2? Nice. So our formula was n minus 2 times 180. So we undo the multiplication with division. We undo the subtraction. Could we do that super algebraically? Absolutely. You could take n minus 2 times 180 equals 720 and then work backwards to solve that equation. But this is the arithmetic portion of it. All right, you've got 2 problems there. You've got the find the x in the, what shape is this? Pentagon, perfect. And the other one is a quadrilateral. What do we notice in the quadrilateral, just to make sure we all know the symbols? Not the 2 sides, but the 2 angles. These are congruent angles. Even though my congruent mark doesn't look perfect, those are congruent to each other. You're going to do those 2. You can partner up for it, please. Go ahead and take care of those 2 problems. Think about what your total number of degrees in that pentagon needs to be. how many degrees this pentagon has to have? Why does it have to have 540? Well, but these don't add up to 540. There's an X there. 3 times 180. So what we just did, the 5 minus 2 times 180 gives me a total of 540. Now how do I get what's left for X? Okay, so if I add the 90, the 90, the 90, and the 135, gives me and X is? Now, as you know, I like to see work. Do I have to see 90 plus 90 plus 90 plus 135? No, if you just write down the 405, I'm going to get that you added up all the other angles. Okay, what about the next one? How many total degrees for that one? 360. Again, you could show me the 4 minus 2 times 180. On this kind of problem, when it's a quadrilateral, I pretty much assume that you already know 360 because you've been learning that one for multiple years. Okay, what do I do now? Okay, 140 is 140. What do I do with it? Somebody else tell me why she's dividing by 2. What do we know about those two angles? Perfect. Because you had the equally between the two. Good? All right, we're going to deal with exterior angles. We've done dealing with the interior angle sum, angles that are on the inside of the polygon. Now I want exterior angles, and I'm going to look at one on each vertex. So I'm not doing multiple exterior angles. Like on the triangle, remember we drew them all out. We could see them all. We're only going to deal with one at each vertex. So when I look at this, how much is this exterior angle next to the 30? Somebody else tell me how she got that. Subtract from 180, so the one next to the 50 is? Somebody else tell me how I get this angle inside the triangle. Okay, so I got 50 and 30 in there, which is 80, so that makes this other interior angle, which means that the exterior is? Can you do that on the other two? Okay, tell me my total on this next one. What's my total on this one? Because it's pentagon again. Okay, go ahead and find your missing interior and your 4 or 5 exteriors on the next two pictures. So all it is adding up to 180 on your interior and your exterior. We'll find missing one inside and then all the outsides. Straight arithmetic here. If you need a calculator, let us know. Numbers with each other. Finding the angles in the picture, you don't need to worry about the step underneath it yet. All right, give me the angle inside the quadrilateral. 105. So then the angle that is next to the 105 is, because they have to add up to 180. The angle next to the 81. Next to the 109, somebody new. And next to the 65. Okay, somebody new, give me the angle that's inside the pentagon that's missing. Okay, what angle is next to the 107? Somebody else next to the 94. Next to the 121. 50 what? Thank you. Next to the 82. And next to the 139. Okay. It's 104. Okay, that's going to change my outside number. 76. Now, do we all agree on those numbers? We're good? Okay, so I want to know the sum of the exterior angles. So the 150, the 80, the 130. How much does that add up to? Okay, somebody else. The 71, the 115, the 75, the 99. All right, somebody new again. 76, 86, 59, 98, and 41. Polygon exterior angle sum theorem. What do all the exteriors always add up to? Beautiful. So notice, you didn't have that fact before, but you were able to still find them, right? This is a new thing that kind of shortcuts the process for you, so you don't have to go through all of that work. You just always know one exterior to each vertex adds up to 360. Regular polygons on the next page. Regular polygons are when all the sides and all the angles are congruent. What word did we use for all sides congruent for a triangle? Equilateral. And what did we use for all angles congruent on a triangle? So they are equilateral and equiangular. So if all the interior angles are congruent, what do you know about all the exterior angles? They're congruent as well, because the interior and exterior have to add up to 180, right? So if I want to find the measure of each interior and each exterior angle of a regular octagon, I know that every single angle inside the octagon is congruent and every exterior angle is congruent, yes? Which one's the faster total to know? Interior or exterior? What do you have to do to find the interior? Exterior is always 360. Interior, we can do this either direction, but to speed your process up, working smarter, not harder, right? All the exteriors always add up to what? So to find one of them, if it is regular, what are we going to do? Where did that number come from? 360 divided by what? How do you know 8? 8 sides means 8 angles, right? So to get my exterior, I'm going to take 360 and I'm going to divide it by 8 because I know all of those exteriors are equal, and each exterior is what? Okay. If my exterior is there and my interior next to it is there, what do those two angles add up to all the time? So if this equals 180 and I know the exterior is 45, how am I getting that interior? Now, that doesn't mean you can't find the interior first. Then you got to do sides minus 2 times 180, get that total, then divide that by 8, and then do 180 minus that one. Doesn't matter. I just think this one's a little faster because you always know 360. You don't have to do any extra work to get that 360. Good? All right, do the next one. Measure of an exterior. Oh, wait, let's do this one together. Sorry. Measure of an exterior angle of a regular polygon is 72. How many sides are there? Yes. 135? You guys just got to tell me when I screw up. Thanks. Good fix. Fix it on your paper too, please. Since I can't subtract. All right, the next one says the measure of an exterior angle of a regular polygon is 72. How many sides are there? How'd you get 5? Because here we divided by the sides to get the angle. So we're going to divide by the angle to get the sides. So it's got 5 sides. Good? Okay, I'm going to leave mine up here. Go ahead and do the next 2 where it says you try. I'm going to leave mine up there so you can still see my work while you are going as well as you have it on your paper. When you're finding one interior and one exterior. So after you find the exterior, go ahead and get that interior. Get that 10 for the exterior. Perfect. Questions? All right. On this next page, we're going to do a little bit of setting up, not solving everything. Okay? So if you have to look at that top problem, what do you think we got to do? Add them all up and equal them to? What piece of information do I need? How many sides? Minus 2 times 180. So I got 1, 2, 3, 4, 5, 6. Yes? 6 minus 2 times 180 gives me a total of. So you would add them all up and equal them to 720. I know you know how to solve the algebra there, so we're not going to bother. But the idea there is just remembering interior angle sums you got to do the formula for. Exterior you know adds up to 360. The next one, where do we have to start? With X, Y, or W, or with Z? Z, why? They add up to 360. So we're going to take our Z's, our Z minus 13, and our Z plus 10, and equal it to 360. So that is 3Z plus what? Or minus what? So since this is kind of a super fast solving, what does 3Z equal? Try again. Got to add 3 to both sides. So what's Z? Again, we're not going to do the entire problem, but if I know Z is 121, how would I get X? If I know Z plus 10 is here, how much is this angle? 131. And then you would subtract from 180 to get Y. Okay, so you just plug your Z back in and then subtract from 180 to get the interior angle. Does that make sense? Are you okay with that process? All right, one last one. Sometimes when we package things like game boards, they have to put them in the box, but they have to fill in corners of the box so that the thing doesn't move around. This is a hexagonal game board, and it's a regular hexagon. I want to find angle 1 and angle 2, and the hint is that angle 1 is an exterior angle of a regular hexagon. How would I figure out how many degrees angle 1 is? What does that word regular mean again? I heard 360. We're going to have a total of 360 from all exteriors. Regular means the angles are equal, so how do I figure out that angle? 360 is the total of all my exteriors. All my angles are equal. How do I figure out one of them? 360 divided by what? How many sides are on that hexagon? 6. So how many angles are there? So angle 1 is? There we go. How would I get angle 2 then? Well, I'm passing out worksheets. Find me angle 2. How much is angle 2? 30 is correct. How do we know it's 30? Perfect. We got a triangle here. So angle 2 is 30. All right, worksheet 3-4 is your homework. Again, it's a packet because the pictures are big, not because there's more work than you're used to having.